So imagine this. You spend hours perfecting your resume and finally decide to submit it to your dream job, only for it to be rejected by an algorithm before a human can even see it. This is not science fiction. It is how most hiring systems work today, and as students preparing to enter the job market, this is the reality. As a junior studying artificial intelligence at Purdue, I've worked on a bunch of machine learning projects and I've studied both their technical capabilities and ethical pitfalls. I have firsthand seen how even the most well designed models can end up having results that are so unfair if you're not careful. This leads to my thesis. While machine learning has the potential to make hiring more efficient, it can unintentionally perpetuate existing biases. Therefore, companies should take steps to ensure that their systems are fair, transparent, and accountable. Today, we're going to go over how bias appears in these machine learning systems, why does it happen in the first place, and finally address the problem with solutions that can fix this. Let's start with the problem itself. So as you know, machine learning tools are already being used in resume screening, ranking candidates, and even analyzing your interviews. But just because a system is automated doesn't mean it's fair. A striking example of this is Amazon's own system that it developed back in 2018. The company developed a resume screening algorithm that downgraded resumes that had the word women, for example, women's chess club captain. According to a 2018 article by Dastans on Reuters, the tool had been trained on historical hiring data that prioritized male candidates for the position. So, unsurprisingly, the model learned to replicate these biases. Also, this is not just limited to resume screening. According to a scientific paper by Raji and Emani back in 2019, they found that facial analysis tools that are used in video interviews also perform their worst on darker skinned women. As you can see in this graph, the x-axis has the error rates and the y-axis has categories based on skin tone. And as you can clearly see, Amazon performs the worst in these charts, followed by Kairos, with an error rate of more than 30% for darker skinned women. These systems can and will disqualify people not because of their skill level, but because of demographic markers. So now that we've seen the problem itself, the most logical question that comes to your mind is, why does it even happen? Most biases, especially bias in ML systems, occur from the foundation, that's data. Models are trained on biased historical data that often reflect previous discriminatory practices. And because the goal of these systems are to maximize efficiency or accuracy and not fairness, this leads to biased predictions. According to Cowgill, Delacroix, and Deng in their 2021 paper, bias rarely stems from bad programming. It rather stems from biased data that's being fed to these models. As Dr. Sandra Walker from Oxford Internet Institute puts it, there's currently invariably a very high, almost impossible to escape chance that there will be some form of bias in algorithmic decision making. What makes this even worse is that most companies treat their algorithms as priority black boxes. Candidates never know why they're being rejected, and employers rarely doubt the outputs of these systems, making bias predictions even harder to find. Let me illustrate this with a simple flowchart. As you can see, first, historical bias data is fed to these models. The models then train with this data. They then internalize these biases and finally make bias predictions. So now that you've seen the cause, let's turn to the most important part of this presentation, the solution itself. So the first and the most crucial step in addressing this problem is regular algorithmic audits. These are just like the financial ones, but they instead test whether these hiring systems produce discriminatory outcomes. Binns, in his 2018 paper, argues that most fairness efforts fail because they ignore the context in which decisions are made. Therefore, regular real-world audits are very important. The next step is transparency. Every candidate must know what criteria were used in the evaluation process and why they were rejected. No one should be disqualified by a machine without an explanation. And finally, models should be designed with fairness in mind. This includes using diverse training datasets, applying fairness constraints on these models for optimization, and finally stress testing these models on multiple demographic groups to ensure fairness. An example that shows that these steps actually work is IBM. So, referencing back to the same 2019 study conducted by Raji and Pulamvini, after public outcry based on the gender shade study that had been conducted, IBM worked on increasing the accuracy of their own facial analysis system and reduced their error rates down from 34.4% to 16.71% for darker skinned women. This is roughly cutting their error rates by half. This shows us that change is not just possible, it has been proven. So, where does this leave us? Machine learning based hiring systems are here to stay, and unless we hold them accountable, they will quietly replicate inequalities from the past. As students and future potential employees, we have the responsibility. In fact, we will end up interacting with these systems, and sometimes, if we design them, have the responsibility to make sure they're fair. Therefore, I urge decision makers to first hold regular algorithmic audits, demand explainability from their model's results, and finally, ensure that fairness is built in from the start. Doing this not only protects the employees, it also protects the company, as it saves them from costly lawsuits, public backlash, and even bad hiring decisions. And so, let's not leave fairness to chance. Let's actually build it in. Thank you.